record so that we can share this with everyone who isn't here today. But thank you guys all for coming. And I'm Chelsea. And this is Courtney and Emily. I'll just go ahead and get started here. We all met each other at the AP reading 2 years ago and got to read again together in Ohio this last summer. And we love teaching APES and we love sharing our best practices. So we're really excited to get to share this with you guys. So I'm going to start by turning it over to Emily.
Okay, so a little bit about me. I teach at a large school in a small-ish community in Indiana called Warsaw Community High School, and I've been teaching for 17 years, and almost every year I think I've taught an AP class. I got thrown into AP Biology in my very first year of teaching at the semester. I've taught AP Chemistry as well, and I started AP Environmental Science 10 years ago. And I have been an AP reader for AP Biology and then now AP Environmental Science for, I'm not quite sure exactly how many years, 15 some years. So my background is biology and chemistry. And part of the thing with APES that's very unique is that everybody kind of comes to it with some strengths and weaknesses. And for me, the geology and the agriculture side was kind of challenging for me because that's not something I had a strong background in. So likely you have some strengths and some weaknesses depending on what your background is too. And that's all kind of part of the fun with AP Environmental Science. So we're going to jump right in with planning. I am one of those people who I am not just like intuitively organized, so planning is super important for me. And so one thing that I highly recommend is the idea of doing backwards planning. And backwards planning is kind of looking at the end and then working your way backwards. So for me, when you look at the CED, you can see, and that's the course and exam description guide. If you haven't found that yet, that's going to be a super important resource for you. In the CED, they give percents for the different sections, for the different units, and you can use that to kind of multiply out how many class periods you have to work with, and it'll give you a little bit of a roadmap of how many periods to dedicate per unit. That'll help keep you on track so that you don't end up in a panic when you're halfway through the school year and you've only covered 2 units. So it helps you to kind of plan that way. The other thing to keep in mind, though, is remember that you're going to have school cancellations. There's things like SAT day and things like that. And also remember that the exam is in mid-May. So you might go into school into June, but the exam is actually in mid. All right, so when we look at planning it out in terms of the order of teaching, this is a huge question that gets asked a lot. And some people like to create their own units, especially if they had those units already in place before. But I really recommend if you're new to AP Environmental Science that you take advantage of the resources that are available to you with these pre-created units, because then everything will match up with AP Classroom and the progress checks and all of the resources that they have. Now, there are a couple of exceptions that are pretty popular, and I actually do one of those. Some people like to start with Unit 4 because they feel like Unit 4 is more of a foundation before they talk about Units 1 through 3. So you could try that. There's a lot of people that do that. I start with Unit 1. However, I take Unit 9 and I distribute the parts into Unit 2 and 4 and 7. So for example, Unit 2 is about biodiversity. So in that unit, I take the parts of Unit 9 that are about the threats to biodiversity and what conservation practices there are, so that it's thrown right in there right after we talk about the importance of biodiversity. So that's a common one as well. The other thing with planning is kind of goes off of what Courtney was addressing. How can you really maximize your class time? And, you know, we all have different schedules. You will find if you search the Facebook group, which I'm assuming everyone is part of, because I think you probably got here from that Facebook group, learning to search through that, and you will find different people have shared some semester-long plans. They've shared how to teach on a block and all different kinds of schedules. One common one is flipping your classroom. So you'll find a lot of resources on there. So you can do flipping your classroom in a lot of different ways. I kind of do a partial flipping the classroom. And what I do is I pull some topics from each unit that they already learned in biology. So, for example, in Unit 1, the information about food chains, they've already learned that before. They might just need to learn a little bit more detail about it. And I put that into video notes that they do as homework. It frees up some class time, so I'm not spending time lecturing on something that I feel that they can do on their own pretty well. Another thing to keep in mind is the importance of routines. Routines really save time. I mean, this is a general teaching tip for me that I have found is so essential. There's a lot of different ways that you can fit routines in, but if there's something that you feel like you're going to forget about or leave out, or if you're not a brand new APES teacher and you know that you struggled with, you just didn't give them enough practice with writing FRQs, consider doing some kind of routine like some people do FRQ Fridays. And every Friday you're going to do an FRQ. That way you're making sure that you're hitting on those different practices as you go through. You could do Math Mondays, and we're going to talk some more about both of those here in just a minute of ways to do math and FRQs. Another thing that gets asked a lot is about textbooks, because that's kind of essential to how you plan your class. And with textbooks, one thing to note is that to be an AP class, you are required to have a textbook that's part of what the College Board program expects. The one that is probably going to be recommended the most to you is the Friedland and Relia 4th edition. That one is the only textbook currently on the market that is fully aligned with the newer course and exam description, the CED. There are earlier editions of Friedland and Relia, as well as other popular ones like Withgott or Miller-Spoolman. These are all great as well, and they have some different pros to them that people really like. If you are using one of those and it's not fully aligned to the CED, there are unit alignment documents available. I know that some of the manufacturers, the publishers have put those out, but also individuals have made those. So you can probably find one of those if you search in the Facebook group or reach out to your textbook. Now, if you're in the situation where the school is saying, we can't afford textbooks, one thing to consider is whether like a digital online access might be a cheaper option than a physical textbook. All right, so the other thing that I want to hit on a little bit is as you're planning.
Emily, before
Yes.
you move off of textbooks, we did have a question about textbooks.
Absolutely.
Does the text come with PPTS that are editable?
I think
Not
that
edible.
depends on which text that you select. Personally, I've never used ones from textbooks just because they tended to kind of be clunky, and they were just using the same pictures and things as the textbook did, and I wanted to use different ones. So that's not a route I've gone, but you can ask the textbook, the like coordinator, those questions. Sometimes it's a separate package. I know that I think for the Friedland and Relia, there's a separate like teacher's package for that.
And I know, like people might have different opinions of this, but I don't know if you guys have ever felt like this. Sometimes if you try to
Me too.
use a PowerPoint that someone else made, another teacher I work with had told me it's like kind of like singing a song someone else wrote, but without the music, that you're like kind of trying to figure out what they meant. And it doesn't always translate. So sometimes if you would like to teach by using slides, I think making your own slides is kind of the way to prepare for it best. But I know it is a lot of work. We'll talk about some other ways to teach without using slides too, without doing just presentations.
And you can also find, even if your textbook doesn't come with them, if you search through the Google Drive and the Facebook group, a lot of people have shared theirs. I would be happy to share mine. I don't know that I've put my slides up on the Facebook group, but yeah, there's probably a lot of other teachers that have theirs out there as well. Those might be a better option instead of the textbook ones. I don't know. I haven't really tried textbook ones in several years. Maybe they're better at them now. All right, so these science practices, I have to admit to you that I kind of ignored these when we first got the CED. I had been teaching APES for a few years. I kept my same units and just kind of tried to roll with it. But I quickly learned that it's really important to not neglect these science practices because you really need to think about how each of these science practices is integrated into the um, the different types of content. Okay, it's not just about the content. This is basically how the content should be delivered. They need to be actively engaged in doing math. They need to be actively engaged in the experimental design process. So it can be really easy to neglect one of these if it's not your strong suit, but make sure that you are working on how to weave these in. And in the CED, they give suggestions next to each of the topics of which science practices work well. I'm really sorry, guys. I have been gifted with a back to school cold, so bear with me here. Okay, the last thing that I want to talk to you guys about before I turn it over is about the labs. We get a lot of questions about labs. Labs can be really intimidating. And now we have these AP Classroom labs. And there are, I think there's 19 of them listed in there. So first of all, please recognize that they are not required. You do not do all of these. These are just resources for you. So as you're going through and trying to decide which one should I try to do, a couple of things to keep in mind. So what materials do you have already on hand? So Lab 9, which is basically a Tragedy of the Commons lab, is a lab that most of us were doing even before this came out. It really doesn't take any specialized equipment, and you'd probably be able to implement that right away without needing to purchase anything new or anything like that. On the other hand, there's the energy efficiency one. I would like to do that one. I have not yet. It requires that you have power consumption meters. It's something I've thought about doing. I've seen a lot of great feedback about that, of getting the kilowatt meters, but I don't have those currently, so I haven't done that one. You also want to consider if you can tie in multiple concepts. So for example, the eco columns, which are not one of the recommended labs, but something really popular with people, people like that they can tie in multiple topics. But again, I've never done eco columns, and other people swear by them. So you can kind of pick and choose what works best. Another thing to keep in mind, as I mentioned before, agriculture, not really my strong suit going into this. At my APSI, we got to choose a door prize, and I chose a Carolina soil properties kit. And that was one of the best things I could have ever done because I knew nothing about soil. And having that clear kit with all the materials labeled and all of the instructions was super helpful for me to walk me through it and get more comfortable with those topics. There are APES bundles of labs with some of those. I don't recommend that just because they're very pricey, and you're not likely that you're going to get through all of those labs or really find all of them very useful. So if you're going in and buying new things, if you have funding available to you, I would recommend picking just one or two, and perhaps think about the ones that maybe you aren't as strong in, because those can help guide you on that. If you, on the other hand, don't have money for labs, some things to consider with that are there are some different classroom grants you can get, maybe locally or nationally. There's also a lot of organizations that can come in and do lessons for you. For example, our recycle center has an education coordinator, and she does lessons in the schools, in the elementary through the high school. She's come in and done the edible landfill activity with my students, which is great fun. They love it, but it's really expensive for me to go and buy all of those consumable things myself. So I love that I can have this resource. They come in and they bring everything with them. Soil and water conservation districts often have educators too, so definitely look into those. I didn't know what a soil and water conservation district was when I started teaching environmental science, and now I love my soil and water conservation district, and they are super helpful. Another one that you can look into are colleges and universities. When I taught AP biology, we used to do a field trip to a nearby university and did our gel electrophoresis there. That's something that needs some specialized equipment. And instead of having to purchase that for our school, the college labs already have that. So the college professors and students led my students in that lab. They got that lab experience. The colleges like it because it's a recruiting tool for them. They're going to say, come to our university. So that's definitely something you could check out. Whichever labs you end up doing, what you want to remember to do is make sure those different scientific experimental design vocab that you are working that in. We don't want AP level labs to be cookbook labs where everything is laid out and they just follow instructions. You really need to get them emphasizing those experimental design vocab of independent and dependent variables, constant variables, control and experimental groups, the scientific question and the hypothesis. Those are going to be things that they need some more practice with. So the more that you integrate those into each of your labs, the more successful they're going to be. And of course, doing calculations. Work in some percent change or dimensional analysis practice into each lab that you do to get them more comfortable with doing the math. So, speaking of math, since I know that's another topic many of you have questions about, I'm going to turn it over to our math guru, Chelsea, and she's going to share some great resources for you.
Hi, everyone. Thank you, Emily. So I am Chelsea Starrett, and I teach in California at a small girls' school where I wear a lot of hats and teach a lot of things. My credential is in math, physics, biology, and geoscience. And I love how Emily talked about which things were a challenge for her getting started. I think that's such a common theme when we're meeting each other in this class was that we don't all start out as experts in everything. One of the things that I had to teach myself was kind of these ecology concepts that I didn't study in college. But sometimes those things that you had to work to learn once you were already a teacher are things that you can communicate better to your students. So maybe if you feel like math is not your thing, maybe math can become your thing and you can become really good at teaching it to your students. I wanted to start out, this is a little bit cheesy, but I think it's important. So some like math affirmations, because I know a lot of us in this class feel like this isn't what you signed up for, that there is like math content and this isn't maybe your strength or your favorite thing. So if little math affirmations. This is from Edutopia. This quote has stuck with me for a lot of years. Another teacher said, most of my work as a math teacher isn't even math. It's helping students believe that they can also do math. So hopefully I can help you believe that you can also do math. So just to remind ourselves, we can learn things. We learn by doing. Mistakes are normal. And then in this class specifically, solving environmental problems requires working with data. And every kind of problem you learn to solve will make you more powerful. Math shouldn't feel like an extra thing or a waste of time in this class. Hopefully, it can become another opportunity to interact with the content in another way. So if this is like a pep talk you need to give yourself or a pep talk you need to give your students, I think it goes a long way to just communicate that the math is a tool and we can master it. So sometimes it can be tempting to just ignore the things that you don't like when you're teaching a class. We've probably all done that at one point or another. So I took some of the data. This one's from the 2024 instructional planning report, looking at the exam and how many multiple choice questions dealt with Science Practice 5, which is data analysis, and Science Practice 6, which was mathematical routines. So I looked at both of those together. And then we also know that in the free response questions section, there are always 6 points given for calculations. So showing the setup and getting the correct answer. And then there's also at least 2 points for data analysis. I maybe should have looked at that again for this year because I feel like sometimes it's more than that of a chart to interpret. So putting all of those numbers together, all of those points from across the exam, around a quarter of the exam deals with quantitative analysis. So things like overlap in one way or another. So this isn't something you want to ignore. This is something that we're trying to help our students like think like scientists and use these tools. So in the past, I had been giving worksheets to my students, even though I did have a background as a math teacher as well. I just had a few worksheets throughout the year for teaching these math concepts. Or we'd look at the little section of the textbook box where we'd work out a solution together. But a broad problem with these, with the worksheets or the textbook questions that I found as a teacher, were that we either had the students found the answers on the internet, and that has become more and more a problem. Even they don't even have to search the problem anymore. It's just AI can tell them the answers. Or when everybody has the same problem, the students are copying each other. So I created a course on positivestem.org. So I'm going to actually take over sharing from Emily so I can show you guys. Let me real quick. Oops, where's my share button? Thanks for your patience. Okay. All right, I'll make this a little bit bigger for us. Okay, so positivestem.org, I'll tell you guys a little bit more about this, but I created this as a resource. I had been using the program for physics. So physics was the original course on here. And then I reached out to the site creator and said, this would be really cool if you guys had something like this for environmental science. And then he encouraged me to figure out how to make it. So that's where we are now. It's still continuously a work in progress. I'm trying to make it better. I have a couple of goals for what to add to it this year. But there's all the APES units on here. So for Unit 1 ecosystems, we have Unit 1, but then I also chunked some of the other units. For instance, Unit 5 is broken up into 3 different units. So you can break it up a little bit more into smaller things. So I'll show you Unit 1 first. This is what it looks like on the teacher dashboard. And I'm going to show you as an example one of the math kinds of questions we have on here, some unit analysis. Okay. So we will have like a lesson. This one is the very first unit analysis skill on the site, and it's just one-step unit conversions. I think it's important to help kids start wherever they're at. And so this is probably a little easier than what they would have to do on the exam in May, but just to help them work up to it. So these are in the context of precipitation and looking at the biome chart and getting familiar with the names of the biomes. So they're kind of interacting with content at the same time that they're practicing the math. And then it'll give them a problem like this. An ecosystem in a subtropical desert biome receives an average of 260 millimeters of rain per 1 year. How many inches of rain does this biome receive annually? And so they can start out with this little like scaffolding and put in their given and check to see if they're getting the right answer. And then figure out how to do their conversion. And then if they put something that's incorrect and check it, it'll just give them like a little X in the corner. So they have the chance to try it again and then try it till they get it right. And then as the teacher, you can see their completion scores, but also their accuracy scores. So to get 100% completion, they have to get all of the answers right eventually, but they don't have to get them all right on the first try. And let's see here what we'd put in for the other ones. So we're converting millimeters to inches, and then we have a given value right here. So 1 inch and 25.4 millimeters is this one. And then to calculate it, the built-in calculator, does this show up for you guys too? Do you see the calculator? Okay, so then this is the Desmos calculator, which is the same calculator that's available in Blue Book. So if you wanted your students to have practice with that, it's available, so they could do that. On the exam, they still are able to use their own calculators as well. And then they can type into the box what the answer was and check their answer. So that's an example of a unit conversion. I'll close that out. And so they have some more practice. If you feel like they need more practice than the ones that are available, you can also reset the skill. And changed it. But every question, every number that's a blue number is randomized. And so if you restart the skill for your students, it will give them a new number, a new set of randomized values, or reshuffle the problems. And so they have a chance to try to think about it again. If they were kind of guessing their way through the first time, a lot of times I'll encourage them to let me reset their scores so they can try it again and like master it. Another skill on here I want to show you guys for Unit 1 is these net primary productivity calculations. So this is topic 1.10, which is one that maybe doesn't have a lot of other like interactive lessons for you. And so it's a formula, and rather than just reading this formula in the book and knowing it, you could let them interact with the data a little bit more. So this one I had done earlier. It has a region of Savannah with NPP of this much kcals per meter squared per year and a GPP of this much. Like I said, those blue values are randomized, so that would change, and then they had to calculate the respiration loss. And then there's some problems where they're looking for a different part of it. So this one also is calculating, this one was going to be calculating the gross primary productivity, and they have to put in their work as they go. And then it's a little bit scaffolded. So as they work through the skill, there's ones that they would have to kind of set up their knowns and unknowns on their own paper or on their calculator to answer it themselves. So that was the NPP skill. And then the 10% rule, one is 111. I'm just kidding. So the 10% rule for ecosystems, this is also one of the topics for Unit 1. And rather than just having students memorize it, if they get to work with the data, that can help. So this one gives us an example of a region of tropical rainforest has 174,000 kilograms of plant biomass. And then we'll use the 10% rule to estimate biomass at each trophic level. And so it has like a little diagram for them, and they can know that the primary producers are the biomass and put that in, and then put in their different values with one less zero at each level, and check that, and then answer those questions for the rest of the food chain. As they go on, then at the end of the skill, they don't have the pyramid to guide them anymore. So it's more like they have to kind of think it through. And then the last one I was going to show you for this part, after they worked through those, there's a lesson to combine all three of those skills I just showed you of 10% rule and a one-step unit conversion and a primary productivity situation. So they kind of have to think a little higher level and put all of those ideas together. So this would be like a multi-step problem that they could work through to answer those things. First, find the net primary productivity, and then convert this area to amount of biomass. And then answer a question using the 10% rule of how much is available to secondary consumers. So working in the math, the required math, but in context. So it's not just like random math, it's like APES math and APES content that they're getting to practice. Besides math too, like I was saying, trying to help with those other data analysis skills. So other units that have different types of graphs that they would have to work with. So for instance, in Unit 3, I broke Unit 3 up into two parts, but age structure diagrams are something that we need practice with. So there's a skill for that. And so there was a lesson, and then there's questions, and then the questions are scrambled, but also randomized to ask different students about different cohorts. So what I like about doing this with my students is I can encourage them to work together, but they'll have different questions. So when they ask each other for help, they're not just telling each other the answers. They kind of have to help each other do it and then also do it themselves. And I think, oh, one last graph I was going to show you guys on here while I was on this one was the demographic transition model was another graph I wanted to show you how I use this. So like really specific types of graphs that are used in APES, just giving the students chances to practice that and interact with that, describes the graph, interpret the graph. And then sometimes there's ones that look like more real data and ones that are more of like a model, like this one is more of a model. And you can, like Emily was saying too, I wanted to add like thinking about those routines. So for me, a lot of times of how I'll teach this is I'll just have a day of the week that will be doing positive STEM. So I'll like teach a little bit and then give them time to work on it, teach a little bit and then give them time to work on it, kind of a I do, you do model. And then whoever is a little bit slower and needs a little bit more time, or like we're saying, like wanted to restart those skills so they could practice them again, they'll do it again for homework or finish it for homework, and using like kind of that flipped model. So I don't have to use class time that day lecturing, we can just do like kind of activities. Also part of my routines is I'll use class time for a lot of free response question practice. And Courtney has some great resources to share for that. So I think I'm gonna hand it over. Oh, yeah, so questions here. We can go back to the slides. So the website, Courtney was writing in the chat that she has, oh yeah, so this is made for everyone. Yes, good question. Thank you for, I should have answered these questions in the chat. I was just on my own screen. So that is for everyone to use. It's like a, you don't have to make your own for that one. You can make your own, but the environmental science one is made for everyone to use. I do have an activation code to share with you guys. So the code START2025 gives you free access through the entire site through October 1st. So you can use it as much as you want for free for all of the rest of August and September with your classes. If your school has money for subscriptions, it's really not very expensive compared to a lot of other subscriptions that I've used before in the past. There's like a little quote button that you can check and see. You could use it for your other science classes as well if you teach physics or chemistry, or bio is new this year too.
Is
And
the screen sharing again? Did I
yeah,
just want to make
thank
sure?
you.
Okay.
Yes, Emily, you're
Because
back on the
people were
screen.
asking
So
about the
this is
activation
the
code.
points
It
I
should be
wanted.
on the screen now.
Yeah, so this is the part I was trying to show. So START2025 is the activation code that's on the screen. So you can write that down to use. I'll email that out again when I email the YouTube. Um, it has all of the 9 APES units broken into 16 like subunits. And besides like that full free access through October 1st, also units 1 through 5 and the reviews are always free. And if you feel like this would be really useful, but there's no way your school would pay for it, there's also a pay what you can option. So if you like reach out to the site creator, Jack, there's like his emails all over the website. You like click on it and just be like, hey, I like using this, but my school's not going to pay for it. And he'll like work out a deal with you. But I think there's like one teacher that was paying $1. I don't know if they want people to know that, but it's like there's like real people that are working to make the website happen. So they want obviously schools to pay for it if they're able to. If your school is not able to pay for it and you want to use it, like the goal is for teachers to use it and for it to help students. So
Well, it's made by teachers for teachers, because I believe Jack was a teacher.
Jack was a teacher. He started
Mhm.
the physics one for his students. He was like a Teach for America teacher in Tennessee and was trying to like figure out how to reach his students and then
Yeah.
develop the thing. Yeah. So trying to make it so that kids and teachers actually use it.
Yeah.
Yeah.
Thank you, Chelsea, so much. And I have to give her a shout out. I used positive STEM last year for my warm-ups in my class, and it was wonderful. just wonderful. So I hope you guys get an opportunity to check that out. All right, like I told you guys earlier, my name is Courtney Gazelle. I teach at Jordan High School in Durham, North Carolina, and this is my 20th year in the classroom, so a big milestone for me. Most of the time I spent teaching freshman earth science, and then in the last 3 years, I've added APES into the mix, which I absolutely love and I'm really enjoying. I've read for 2 years, learned a ton. Once you guys get going, if you get the opportunity to be a reader, I would highly encourage it. It's great professional development, and it has really upped my classroom game for sure. I have a bachelor's in earth science and I have a master's in science education. So the ladies asked me to take on FRQs tonight. And my best advice to you is don't be afraid of FRQs. Students can smell fear. So you got this. And I'm telling you this because I'm speaking from experience. I was basically voluntold that I was going to be teaching APES 1 week before school started, and I had not taken an APSI. I had no AP experience. So there were literally nights that I would watch the daily video and then the next day go to class and teach it. Like, so, and that first year, I hardly spent any time on FRQs because I was just surviving, and I was very afraid of them. They seemed very intimidating to me. And I kind of regret that because I feel like in May, my students suffered because of that. And so I've worked very hard to up my FRQ game in the last couple years, and I'm here to share with you what has worked for me and my kids. So I'm going to start by talking about the difference between everyday FRQ practice and testing FRQs. Very different. And the best advice I can give to you is do not give your kids full-on full-on FRQs to practice in class. You are going to burn them out. They're going to shut down on you because there are a lot. A full-on FRQ is actually 10 questions. And so, what you want to do, what we have found to be more beneficial for the student is to chunk them. Just every day or like maybe 2 or 3 times a week, just give them one question. And they make great warm-ups. And if you do it consistently and you add variety, you're gonna see your FRQ writing quality go up, and you're also gonna see the confidence of your kids go up. And I think the kids really appreciate the immediate feedback that they can get by just doing a small one every day. Now, when I say variety, as you're going to see on the next slide, there are many different task verbs that the kids are going to see. I mean, you've got your easy ones like identify, describe, but they also are going to have to calculate and they have to analyze graphs and all that. We have found that the two that students struggle with most are where they have to read a passage and also where they have to analyze a graph or a map. So you need to make sure you're throwing those in the mix so that you can talk about it and build up their knowledge on those. Okay, now let's talk about testing FRQs. This one you have to make as close to what they're going to see in May as possible. Your FRQ needs to include 10 questions. They're going to have to do 3 different FRQs, 10 questions each, and it'll be a mix of task verbs. So you need to build them up to that. I'm not saying that like in unit 1 or 2, you need to hit them with 10 right away, but I'd say by at least unit 4, if not 3, you're giving them 10, a full FRQ. And also you need to time them. Once again, if you don't want to time them for unit 1 and 2, totally understand, but you have to start timing them because they need to build testing endurance. They need to learn how to skip the hard ones and do the easy ones and then come back. They need to practice analyzing quickly, writing out their thoughts quickly. For each FRQ, we recommend 22 minutes. And then lastly, don't take it easy on them. I know it's really easy to be like, oh, I know what they meant, so I'll give them the point. Don't do it because as a reader, we get a rubric and we have to stick to that rubric. We can't be like, oh, I know what they meant, so I'm going to give it to them. Like you gotta lock it down. So if we go to the next one, I'm going to give you my 5 top resources and practice tips. Okay, so I would say implement this tomorrow if you can. I've created an FRQ boot camp. And I take like the first month, and every Friday we'll watch a short YouTube video on writing strategies, how to write the math FRQ, how to write the experimental design, yada, yada. And then I've created handouts for the student to fill in as we watch the video. And I tell you what, like it has helped me. It has helped my kids' confidence go up. Their writing is a lot more clear and organized. Definitely worth the time. Okay. So that link will take you to that Google folder and you have everything you need in there. The next two actually go together. It's a handout that I give my kids on the first day of class. So on the front side, and you can see the previews I've put there on the left for you. So the task verb graphic organizer has all of the task verbs on it and a short description underneath with like how many sentences you should expect to write, what should be in it. So that's the front side of my handout. And on the back side, I print this math keyboard entry worksheet, which is from College Board, and it tells the kids how they want their math typed in. This is extremely important. College Board doesn't just take anything. Like they need to type it in a certain way. And so they need to practice that. And so I give them this handout and I actually have them pull it out for every test. And you're probably thinking, well, isn't that an open notes test? But it's not, because there's no content on that handout. We need our kids practicing the task verbs, practicing typing in the math. And it's a great way for a great resource for them to see it and do it right and not just be guessing. So I'd highly encourage you to print that tomorrow. The next thing, actually, I got this from Chelsea, is a peer grading PowerPoint template. One of the questions that we got in our Google form was, how do you keep up with all the grading? And I had to laugh when I saw this question because I have graded every single FRQ for the last 3 years. And then in one of my professional developments last spring, I was noticing a lot of teachers do peer grading. And I'm like, oh my gosh, like, how do you give feedback and all that. And so I was talking to Chelsea about it, and she's like, oh, well, I use this peer grading PowerPoint. Oh my gosh. Peer grading is not a free-for-all. It is a very structured activity that you do with the kids. And so I would use this template, adjust it for yourself, and you walk the kids through slide by slide and you grade the FRQs together. And it's a wonderful activity because we have also found that if kids can score an FRQ accurately, they can write FRQs more accurately. So they're getting double the exposure. I would highly encourage you to do it. Now, once again, I would probably, well, I am going to grade my students Unit 1 and Unit 2 FRQs just so they can get a feel for what specific means to me and get that teacher feedback. But Unit 3, we're going to start peer grading. And then lastly, our FRQs, which I want to go, FRQ stations, I want to go into more detail. Like I told you, in everyday FRQ teaching, you need to have consistent, small exposure. So I've developed these FRQ stations, which in the previous slide, I linked my Unit 2 FRQ stations for you, so you can try them right away. You guys all know how to run stations. I cut up the worksheet, put it around the room. They get into groups of 2 or 3, and we rotate through the stations. And it's a great way to get them up and moving. It brings in collaboration. We get to peer grade or self-grade again. So they're getting that double exposure. They get immediate feedback because we'll all sit down and we'll go over it together. And then lastly, it's concept review. So I always save these for like either the day before or 2 days before the test. And yeah, it's a lot of bang for your buck. And so I'd highly encourage you guys to check that out. So that's FRQs in a nutshell. Um, we went through all of your guys' questions, and I'm so sorry that we weren't able to touch on all of them. But here in the resources slide, we were able to pin a couple extra things that we thought you guys would find helpful. And I'm sure Chelsea, Emily, and I will take time to email you guys who did not get your questions answered if we can. But the two that I wanted to post for you were my ins and outs of AP Classroom. I'm a co-chair for our AP department at Jordan, so I get to work with all the subject areas, and they wanted PD on AP Classroom. And so that's the PowerPoint I used. Teaches you how to assign things, uh, grade, like all the things for AP Classroom. Don't waste your time making your own test. Use AP Classroom. The wording is the same, the format's the same. It is a beautiful tool that every APES teacher should be using if they can. Okay, so that should help you with that. And lastly, we had quite a few people request a pacing guide for a 90-minute class period, which I teach. So I put my planning guide on there for you for August and September. I didn't do the whole year because we all have our own personalities and labs we like and all that. I just wanted to give you kind of a taste of how much you should be doing every day in class to stay on pace and keep moving. And I linked all my activities, notes, and videos for you in my planning guide just to get you started. And they're all my tried and true ones that I've pulled from the APES Facebook page that we all know work and cover a lot of content. And so I hope you guys find that helpful.
Courtney, are your other FRQ stations for the other units part of that?
I have a Google folder with FRQ stations, and if you guys would like me to link that before we send out the PowerPoint, I'm happy to do that.
Another question was asked about the other formats. We didn't have any linked in here, but if you search on the Facebook group, there have been lots of different ones that have been shared
Mhm.
as well.
Yeah.
The other two that we linked on here, field trips, get asked about a lot. It is AP Environmental Science. It's about the environment. We want to get them out of the classroom, but that can be really intimidating. I just threw a whole list on there of ones I've done, but also ones I've seen other people do as some ideas. And some of them are super simple. You might not even have to leave your school's property. For example, going on a trip to your school's boiler room. Seriously, it's the most fascinating thing ever. So you don't even have to leave the school campus. But I've given PD specifically on how to do field trips. So if that's something that you want more info on, feel free to reach out to me about that. Or if you're reading through that list and you're curious about how to do any of those. The other one that I linked, some people have asked about grading scale and how do you grade at an AP scale. And so I've linked what I use. It shows how you take and you give them an exam that is at an AP level, but yet you don't want to tank their GPA in class. Because what I always tell the students, you really have to prepare them for this, guys. If you don't, then they get to the AP exam, then they shut down because they're missing, they're thinking, I'm missing too many questions. But if you're getting 75 to 80% correct on the AP exam, you're on track for a 5. And a lot of our honors kids, a 75, 80%, they consider that failing. That's not an A, right? And so you have to kind of get them used to that. So this grading scale is what I do to help to facilitate that so that I'm giving them the time crunch, I'm giving them the AP rigor, but then I have that adjusted to what, the school GPA considers passing and that kind of thing.
We had a couple other questions in the chat. Another field trip idea that's just more of going outside too. We just go do like quadrats or transects for like biodiversity data out on the JV softball field that's like covered in weeds. So that's if you have something like that, that's just like neglected lawn. That's a fun place to go get some data too. Um, and oh, we have a question. What do you do in the boiler room, Emily?
Just have our head custodian gives us a tour and shows them this is how we get heat, this is how we get Air conditioning, they give statistics, which is it's great fun, guys, to find out what the monthly budget for heating and powering a school is, for how much snow removal costs. It blows their mind. A lot of them don't even know what typical monthly budget is at home, and it's great to say, hey, like ask your parents how much, if you own a home, how much it costs to power the home. But you will be shocked. Snow removal costs like $30,000 for my campus,
Oh.
every time. So that
Oh.
just kind of blows their mind to learn about that. So.
I would like to talk about one question. They asked, do any of the presenters use a textbook? I wanted to let you know I've never used a textbook. I just use all the daily videos. However, um, one of the AP readers I met, she will just pull like snippets out of their textbook for just readings and then like some little questions. And I think she has great scores. So I think readings are important. Um, and we have textbooks in the classroom, but we've just used videos.
And then I teach out of the fourth edition of Friedland and Relia. It was the first one that Emily mentioned. It's on one of the first slides because it's so well aligned with the textbook. And I don't teach vocabulary separately. I think that's something that the kids kind of interact with, although there are a lot of vocabulary application problems on the Positive STEM website as well, so that they can practice applying things. So for instance, like they're never going to just have to be able to repeat like the definition of an R selected species, but they definitely do need to know, like, given a description of something, is that R selected or K selected? So they don't have to know like every animal there is, but they would have to like be able to understand a description of them, like, oh, they have, they lay 7,000 eggs. That's R selected. So working with the content and examples, I think it's a lot more application based. Yeah, yeah, they exactly. So the I think then the textbook or daily videos might help with that introduction of the vocabulary. Probably I would say the textbook is how I would have them be introduced to the vocabulary.
And I think it's great that everybody has different answers because I use the Friedland and Relia fourth edition too, but my students do reading quizzes. So I do assign reading in it and they're open book quizzes. So I encourage them to use sticky notes and they can write things on those and like as they read and then they can use their textbook when they are taking their quiz. But there's not a right or wrong, answer here. You can do what is comfortable to you, in terms of using it as a resource or having it be something that you're actively integrating in the class. And I think the same goes for the labs because there's some questions being asked about labs, and everybody has their like favorite ones. I think that the tragedy of the commons one that I mentioned earlier is a common one, whether you do that with goldfish or Fruit Loops or Cheerios. And there's different variations out there for that. And it's also just one that doesn't take a lot of equipment. It doesn't take, anything specialized. I agree that someone had said, so a soils lab, I think is really, really helpful to do a soils lab. That's why I was so glad that I had that kit that I was given. The other one that I think is really helpful is just doing something where they are setting up and manipulating different variables and doing anything with growing seeds can be really helpful. There's a soil compaction lab that's in the AP classroom, and I did that one for the first time last year, and that was great. But you could do anything where you are varying how much water that you're giving things, or you're varying the salinity. I think there's a salinity one in there. Any of those are going to be really helpful for them. For the pacing guides, I don't have a pacing guide for mine in particular. I mean, I guess I could kind of try to figure that out. I've never written it out on one document, but I do teach with the like 45-minute classes all year long. But I know there's got to be some pacing guides out there if you search in the Facebook group.
Sure. I was gonna add too for that, like it does. Oh, we're almost out of time. I don't know if it's gonna cut us off.
Okay.
Okay. But just in case, we'll just finish this up. And then if you have more questions, reach out to any of us on our email. I think that's on the last slide. And then I will be sending up a follow-up email with all this tomorrow. But I think for figuring out your pacing, it's really important to know what your end date is of, well, we all know our end date is the AP exam, but your start date for school will change things, how fast you can go. And then also the, like when your school takes breaks, like Emily said, you want to build in time for snow days and stuff like that. My schedule is 3 45 minutes periods and 1 75-minute period a week. So it's like all over the place, but all of that. Hopefully, thank you, is helpful. I'm really glad we all got to share with you guys tonight. And oh, I'm so sorry that's so late. It's September 8th start. But yeah, we're all dealing with our things. It's great to talk to you guys, and hopefully we'll see you around. Oh, happy first day. See you around in
Thank
the
you, everybody. Have a great school year.
Bye.
Email us, please. Please email us. I know that we went through things fast and we will answer your questions.
All right. Bye.